Hi, and welcome to our tutorial on paper faults. These are paper faults whose origins are at the wet end of the paper machine. The most common fault that people refer to, of course, is often formation. So we might ask ourselves, what is the definition of formation? Well, formation is really the evenness or unevenness of a sheet when viewed through transmitted light. So here's an example of a sheet of paper with good formation, where everything is relatively even, and here is a very good example of a paper with bad formation, because you can see there are many light spots and dark spots in a very random configuration. So formation is a problem. What causes formation problems? It can be related to fibre length. The longer the fibres, the more they are likely to get entangled and cause formation problems. It could be to do with degree of fibrillation. The more you refine fibres, the more you fibrillate them, the more they will be entangled. The harder it is for them to fall down onto the forming fabric randomly without any interference from any other fibre. There are other causes of formation as well: drainage rates, chemicals. Two-sidedness is another problem that happens with paper. Ideally, we want the printing characteristics on one side of the sheet to be exactly the same as the printing characteristics on the other side of the sheet. And if we achieve that, we say we have a paper that is not two-sided. If the sheet characteristics are very different for printing, then we have a two-sided sheet, and that's what we need to avoid. What causes two-sided sheets? Well, here you can see one frame of the forming fabric. You can see the filaments that make up the frame. You can see part of one fibre going across the frame, and other things that are there in the furnish, filler particles, fines, etc. Well, when your fibre matrix is coming down and forming a layer on the forming fabric, as each layer builds up successively, it becomes a filtration mechanism, and we catch smaller and smaller and smaller particles. At the bottom, however, all these particles can get washed away if you're not careful. By washing them away, you'll create a very rough underside to the sheet that's predominantly fibres with no fines and no filler particles there. As the layers build up on top of that, then you'll catch smaller and smaller filler particles and fines, so you'll have a much smoother top surface. So two-sidedness is all about avoiding that situation. There you can see what typically happens with single wire dewatering. On the top side, it becomes very smooth, and as you work down through the sheet, the smoothness falls off, it becomes rougher. If you look at double-sided dewatering, where you're removing stuff from both sides of the sheet, you can see that both outer sides are the same. Another thing we need to consider is efflux ratio. Efflux ratio is the speed of the stock coming out of the slice relative to the speed of the wire. And there are two situations here. There's what's called the drag situation, and there's what's called the rush situation. In the drag situation, what's happening there is the wire is travelling fast, the stock is coming out of the slice at a slower speed. As the stock comes out at a slower speed, fibres could be in any orientation. So a fibre may come out in that sort of orientation onto the wire. When the wire starts to move off, the fibre comes in line behind it, and all the fibres therefore line up in the machine direction. That gives you a really good machine direction tensile strength, but a very poor machine direction or cross direction tensile strength. In the rush situation, the wire is travelling along at one speed, the fibres come out at a faster speed, and the beginning of the fibre hits the wire. The front of the fibre will immediately slow down to the wire speed. The back of the fibre will keep going faster and will tumble over and it could land in absolutely any orientation. So the fibre distribution or the fibre alignment distribution will be a lot more random. So the strength in the cross direction is very likely to be the same as the strength in the machine direction. And so you'll have a much more square sheet, as we call it. And final thing really is just to talk about uneven drying. When your sheet goes into the dry section, it could come out with this sort of cockled appearance. And this is usually because things have gone wrong in the wet end. And what's happened in the wet end is that there's a lot of basis weight variation. If you have a large basis weight variation, then when you come to the dry section, the thin areas of the paper will dry quick and they will pull things in, and the thicker areas will dry more slowly because they hold more water. These variations in grammage, there are two main reasons. One is you have an incorrect slice profile, and the other is if you've got wire ridges. And you've got wire ridges, fibres will tumble down into those ridges and give you thicker areas. So wire ridges and slice profile are the main contributors to poor basis weight profiles and therefore poor drying. So to summarise what we've said in this section, formation is the uniformity or lack of uniformity of the sheet. It could also be described as the density of mass distribution, if you're mathematically inclined. Formation is also known as look-through or see-through. Two-sidedness is due to the washing away of fibre or filler or fines from the wire side of the sheet during the formation process. Efflux ratio, when the wire is going faster than the jet, fibres get aligned in the machine direction, so we have a high machine direction strength and a low cross direction strength. If the wire is travelling slower than the jet, the fibres are more randomly oriented because they tumble over in unspecified directions. And finally, uneven drying is due to poor grammage control due to the slice problems or wire ridges. Thank you for listening to this tutorial, and I hope you enjoy